So the next thing we want to be able to do is we want to be able to shift our functions horizontally and vertically. Now, all of those shifts that we studied way back when in algebra, and where we shifted an entire shape of the graph upward or downward by some constant c, or horizontally left or right by c, are going to apply to these sine and cosine functions in the same way. The only difference right here for us is that when we say we shift horizontally, we call that a phase shift. So our phase shift is what we're going to be looking at. Now, here's an example where I just do a simple horizontal shift. If I said y was equal to sine of x minus pi over 3, what that would mean to me is that it would be the equivalent of taking my function and shifting everything to the right by pi over 3. So you can imagine it that way. What would that mean? If I had one cycle that would normally have started at 0 and ended at 2 pi, then all of my x values will have been shifted to the right by pi over 3. So instead of starting at 0, we'd start at pi over 3. Instead of being midway through my cycle at pi, I would be pi over 3 more, so I'd be at 4 pi over 3. Right? And instead of ending one full cycle at 2 pi, I'd have one full cycle ending at, let's see, 7 pi over 3. All right, well, how am I coming to these numbers right here for my shifted graph, right? Here's one new cycle of my graph after the shift by pi over 3 to the right. Well, if I were doing this analytically, I wanted to figure this out, I'd want to figure out what's happening with sine of x minus pi over 3. So here's my reasoning. In this graph that I'm showing here in blue, what's going to happen is that our amplitude hasn't changed. It's still equal to 1. And our period is still the same as it was in our original function, that's 2 pi. The only difference that we have now is that everything is going to be shifted. Well, in my period, right, when my normal sine function, each of my key points were pi over 2 apart, right? And that was 1/4 of the period apart. If you take 1/4 of the period 2 pi, right, my key points are pi over 2 apart. So how is that going to work out? Well, in this case, since everything is starting pi over 3 to the right, I call that my phase shift. And the way I always figure out my phase shift is that I just take my original function and my argument and set it equal to 0. So where does x minus pi over 3 equal 0? Well, clearly in this case, at the point x equals pi over 3. That becomes my new starting point in my table of values. Okay? And since each of the key points are pi over 2 apart, I'm going to take pi over 3, I'm going to start adding increments of pi over 2. Now, a lot of people don't like dealing with fractions because, well, they're fractions. But actually, this is pretty easy if we take this off to the side. Pi over 3 and pi over 2 share a common factor of 6. Pi over 3 is the same thing as 2 pi over 6. And what's going to happen is that we're going to start adding increments of pi over 2, right? Pi over 2 is the same thing as 5 pi, is the same thing, getting ahead of myself, is the same thing as 3 pi over 6. So our 3 pi over 6 increment is what we're going to be using. So 2 pi over 6 add 3 pi over 6, that gives us 5 pi over 6. If we add 3 pi over 6 again, we get 8 pi over 6. We add 3 pi over 6 again, we get 11 pi over 6. Then we add 3 pi over 6 again, and we get 14 pi over 6. All right. Now we should reduce each of these to put them on our table so we can use it on our graph, and that gives us key points here. Let's see. 5 pi over 6, which doesn't reduce. 8 pi over 6, which does reduce to 4 pi over 3. As we said, that was the halfway mark here on our graph. We take 11 pi over 6. That does not reduce, 11 pi over 6. And then we add our 3 pi over 6 again, 14 pi over 6, and that does reduce to 7 pi over 3, which is where we have 1 full unit ending. And since the amplitude is 1 and we have it reflected, all of our y values will be the same as they were before. So we'll go through 0, 1, 0, -1, and 0. And we keep that same pattern going. So we can see within one cycle of the graph how this horizontal shift actually works as compared to that the sine graph. And so we're going to use this in our next videos to show how we can get some more complicated looking functions very quickly.